So lecture 23, radian and degree measure. So in this lecture, hopefully be able to determine the angles and degree measures, right? Uh, and also convert between degree measure and radian measure. Right? There's a formula that you can use to do that conversions and find the coterminal angles of an angle. All right. When you have the trigonometry, you no longer just measure x and y. You use some rotations of an angle to measure some to identify the locations of a point on a circle or on a plane. So you have, in this case, the two-dimensional or the 2D plane. Okay. If I starting from this positions right here on the horizontal line, I'm gonna do some rotations, counterclockwise rotations, and I'm going to arrive at this particular uh, line segment right here. Right. So when I do that, I have something, this starting point right here, this side is called the initial side. And the side that I finish at or I stop at is going to be called the terminal side. Now from the initial side to the terminal side, I actually just make a rotation counterclockwise, and I form an angle, and I call that angle theta. And the positions of this angle is in the standard position. So theta is in the standard position or direction. Right. So standard position or direction is that counterclockwise direction. When you rotate starting from the initial side to a terminal side, counterclockwise, the angle that formed from this rotation is a positive angle. So counterclockwise rotation is a positive rotation. Clockwise rotations is a negative rotation. So the positive angle like this, same here. This is theta. And in this case, theta is positive. So this is positive angle. Counterclockwise. So you have the terminal side here as well. But the rotation starting from the initial side is clockwise. So you go like this. This angle is negative. So this is negative angle. This is clockwise rotations. So when you say angle measurement, that means you want to know how much the angle is rotated. Right? So this is a measure how much an angle is rotated. So it's just a general definitions. Okay. And the value of the angle depends on how you rotate as well. Are you rotating counterclockwise or are you rotating clockwise? Counterclockwise, you have a positive rotation. Clockwise, you have a negative rotations. And there are two ways to do the measurement. The first one is degree measure, and the second one is the radian measure. Now, the definitions I want to give you is called the coterminal angles. So these angles, like coterminal angles, are angles that have the same initial sign and terminal sign. Now, if you have a different colors pen, it's very helpful when you look back at your notes to indicate different coterminal angles. So let's say you have this is the terminal sign. Okay. So from the initial side to the terminal side, this is our standard angle positions. Theta. So now again, the coterminal angles are angles that have the same initial sign and terminal sign. Starting from this initial sign, we can go in the clockwise directions, right? And that's called alpha angle. So theta and alpha are coterminal angles, again, because they have the same initial sign and terminal sign. Now, there's another situation. Yeah. So in a way, the coterminal, there are infinitely many coterminal angles. Here's what it's going to be like. You have a different coterminal angle. So starting from the initial sign, so this angle is beta. So you do two rotations of theta to get to theta. So in this case, alpha, theta, alpha, beta are coterminal angles. So theta, alpha, and beta coterminal angles. We can go triple count after triple, single, double, triple, quadruple count. But double count. Okay. All right. So as a matter of fact, there are infinitely many coterminal angles because the restriction is that you have the same initial sign and terminal sign. So that's why when we talk about coterminal angles or when you try to identify coterminal angles, we always restrict ourselves to certain interval, usually between 0 and 2 pi. We'll get to that later in the lecture notes. Some of the lecture notes. But for now, hopefully you know how to identify coterminal. So radian measure. So how could you identify one radian? So the angle that is made by taking the radius and wrapping it around the circle. All right. So I have this circle. You know about circle. If you don't remember about circle, you should go back to lecture 7. We spent a little bit of time on circle, how to identify, how to find the center, how to find the radius, how to write the circle in the standard form or in the general form. Okay. So if I have this circle, the radius is r. Okay. So let's say this radius is r. Okay. Mm, This is radius r. And this angle we have here is theta. All right. Now, how would you take the 1 radian? So this is r. Okay. You take a straight line, you bend it, and place that on the circle, and that's how you measure 1 radian. You would hear that. Okay. So that's 1 radian. The circumference of a circle with radius r is equal to 2 pi r. All full revolutions this is 2 pi radian. So the short name for radian is RAD. The half revolutions is pi radian. And 1/4 of a revolutions is pi over 2 radian. Okay. So by conventions, you always start at this point right here, and that is point is 0 radian. That means there's no rotations or the initial side and the terminal side kind of lie on top of one another, and you have 0 radian. If the terminal side perpendicular to the initial side, we have a 90-degree angle or pi over 2 radian. You have half a revolutions, or half of an angle, you have pi radian. You have 3/4 of a circle. That is 3 pi over 2 radian. And when you complete the entire circle, you have 2 pi radian. Now, degree measure. So degree measure angles. In terms of degrees. So corresponding to the radian measure, the full revolution is 360 degree. For half revolutions, you have 180 degree. In the quarter of revolutions, you have 90 degree. So this angle I give you are special angles. We will learn more about different special angles later on in the course. But I want to start out with by giving you some easy to remember special angles. So 0, 90 degree, 180 degree, and 270 degree, and 360 degree. So corresponding to the 0 radians, we have 0 degree. Pi over 2 radians corresponding to that is 90 degree. Like right here, 90 degree. Corresponding to pi radian is 180 degree. 3 pi over 2 radian is 270 degree. And corresponding to 2 pi radian is 360 degree. How many of you have seen this materials before? So I kind of like slowing you down, get in your way. Here? Okay. Can I spit it up? Okay. All right. You good, Aaron? Have you ever wondered why 360 degree? Not something else. All right. So there's 2 theories to this, dating back to thousands of years ago. The first theory is that Babylonians, about 4,000 years ago, they used a certain number system. For us, the number system is base 10, right? For the computer is base 2, 0, 1, 0, 1. So that's how they communicate. For the Mayans, right, in Mexico, they use base 20. Why? Because of tens of years into those. So that's base 20. Babylonians, that's how they spell it. They use base 60 because the 60 can be divisible by a lot of numbers before that. is divisible by 1, 2, 3, 4, 5, 6, not 7, 8, not 8. Is that divisible by 8? No, not 8, 9, 10, 12. I mean, a lot of number from 1 to 60. So they use base 60 in trading to trade goods and whatnot. So that's one theory because of base 60, it can easily go to 360, very even number. And for 360, because of that, it's very easy to break the circle into 2 parts, 4 parts, 6 parts, so on and so forth. So that's one theory that leads to 360 degrees for full circle of revolutions. Another theory is that back in the day, remember Babylonian is way back in the day, 4,000 years ago. They estimate that the Earth will complete one circle around the sun 360 days. Yeah, approximately 4,000 years ago, not 365 as we know, but 360 days to complete the full cycle. So that's why the number 360 and not other numbers. Like that's good that they estimate at 360 days and not 361 days. Otherwise, it's going to be very awful for us to do math, right? All right, so those are the two theories on why we have 360 degrees. All right, so then example 1 here that give you some practice on how to identify an angle here. So at this point, it's a lot easier to just do degree measure instead of radian measure. But later on, you will see it's very convenient to actually use radian measure. So for instance, draw each angle here. You have positive 45 degrees. Remember, the first part here of the 2D plane is 90 degrees, so half of this is 45 degrees. Now here you have negative 90 degrees, remember 90 degrees, but in the clockwise rotations instead of counterclockwise rotations. So you have negative number 225 degrees, so the rotations is counterclockwise, but you go past 180 degrees, okay, add another 45 degrees to get to 235 degrees. So for 45-degree angle, so half of 90 degree for negative 90-degree angle, you rotate the angle clockwise. Give you negative 90 degree. And for 225 degree, you go past 180 degree and then add another 45 degree. Now I'm gonna, any questions on example 1? Straightforward. Yeah. Okay. So 225 degree is also a special angle. We will encounter that when we get to the circle. Now to convert between the two angle measure, right? We have a formula. So now I want to convert from degree to radians. I have one formula. I want to convert radian back to degree measure. So here are the formula. From degree measure to radian measure. You multiply the angle by pi radian over 180 degree. When you want to convert the radian to degree measure, you multiply the angle by 180 degree divided by pi radian. So you just flip this fractions back and forth. Now, example 2, we're going to utilize this formula to convert from one degree measure, from one angle measure to another angle measure. So here, let's start with 135 degree. All of this are, only the one that is have some special angle to it. So again, you will encounter that when you get to the unit circle. So 135 degree, I want to convert this into radian measure. So what I do is I take 135 degree and multiply with pi radian divided by 130. So I have 135 degree multiplied by pi radian divided by 180 degree. So the degree cancel out, right? And you're left with just one unit, in this case the radian units. That's why you convert from degree measure to radian measure. You okay with that? Alright. So now can you simplify 135 to 180? 180. What is that simplifying to? 135 and 180. You do it before. Both number divisible by 5. Let's start with that. Twenty-seven, 36. That'd be a good start, yes. So 135 divided by 180. We say 27 by 36. Okay, so that's a good start. So you can go further than this. So 27 and 36 divisible by 4, right? So divisible by 9. So 27 divided by 9, you have 3. 36 divided by 9 is 4. So 3, 4 is the simplest form of this fraction. So here you can convert this into 3 pi over 4 radian. Now for 580 degree, you want to convert that to radian measure. You do 540 degree times pi radian divided by 180 degree. So what is that equal to? Yes, 3 pi. So 540 divided by 180, you get 3 even. Okay, so that's how you convert from degree measures to radian measure. Now moving on to C and D, now you convert from radian measure to degree measure. So negative pi over 2 radian to degree measure, what you do is you do negative pi over 2 radian multiply with 180 degree divided by pi radian. The unit radian cancel out and you're left with the unit degree units only. Let me quickly do that. The radian cancel out. And also pi cancel out. And you're left with negative 180 degree divided by 2. Or this is 90 degree angle. Negative 90 degree angle. Good questions? Now the next problem, 9 pi over 4 radians, convert that to degree angle. You do 9 pi over 4 radians, multiply with 180 degree divided by pi radian. So the radian notations, so units, sorry, cancel out, pi cancel out, and you have 9 over 4 times 180 degree. So can you do a quick calculations and give me the answer to this? Yes. 405. Yes. All right, so remember in the quiz or in the test, you are not allowed to use a calculator. So the conversions that I'm going to give you in the test or in the quiz should be easy enough to be something that you're familiar with. Okay, so 405 may not be more difficult problems. Any questions? Concern? Tired?
Could you go more into the steps of how to do that? Maybe yeah.
Okay, so as I mentioned, this is probably a part of calculations because we don't calculate that. Okay. There's two ways to do that. First, you can do 9 times 180, okay, and then divide it by 4. Yeah. And then, I mean, if you have a calculator, it's a lot easier to just divide 4 by 5. Okay. Another approach to do is first you do 180 degree divided by 4, just quicker, and then you get 45 and use 45 times 9. So that's a quick way. Good. So for radian measure, I just write the number, not gonna write the unit and then. Yeah, correct. Oh yes, pi over 6. Good. All right. So for some of you, if you are still struggling with the conversions, the idea is so you have 30-degree angle, you multiply with pi radian divided by 183. Okay. So the degree cancel out and you're left with just radian measure with radian units. Okay. And here you can write this as 30 divided by 180. Sorry, 30 pi divided by 180. And you simplify 30 over 180, and you get 6 or 1 6. So pi over 6. Good? Yes.
If you're at 165, is that okay?
That's okay, totally fine. But, sorry, it's fine if you write 1 over 6 times pi, totally fine. But by conventions, in all the textbook I have known, in any course majors, the convention is pi over 6. Okay. Or pi over number. Or earlier you do conversions of the degree to 3 pi over 4. The pi is always get written together with the number of them. Pi over 6, 45-degree is pi over 4. Yes. What about 60-degree angle? Pi over 3. What about 90-degree angle? Pi over 2. 180-degree pi. 270-degree. 3 pi over 2. And then 360-degree at 2 pi. Again, you're going to encounter these angles over and over again. All right. More important. So this angle are very important. So 60-degree angle, pi over 6, pi over 4, pi over 3, pi over 2, pi, 3 pi over 2, 2 pi. Please memorize this. I haven't asked you to memorize a lot of formula in this course, right? So, but this angles are very important to memorize. Right, so finding coterminal angles. Again, let me show you the definitions of coterminal angles. So coterminal angles are angles that have the same initial side and terminal side. There are infinitely many coterminal angles, but for the last page, the work we're going to focus on only restrict ourselves between 0 and 2 pi, so 0 and 360 degree. So angle, again, the first bullet is just definitions. So coterminal angle are angles that have the same initial side and terminal side. Second bullet, is there are infinitely many coterminal angles. Finding coterminal to find coterminal angles. Remember, you have two angle measures. One is with degree measure and the other one with radian measure. So for degree measure, what you do is you add or subtract 360 degree. Whatever this means. When we get to a specific problem, but for now, that's kind of the concept that we need to apply. Now for radian measure, you add or subtract 2 pi. Now for the last bullet, it's going to be the restrictions. So we restrict coterminal angles in the interval of 0 and 2 pi, or 0 degree and 360 degree. In both counterclockwise and clockwise rotations. Good. Good with the theory. You copy it down. It's very vague, right? So here's how you find coterminal angles. So for example 3, multiple choice questions here, the angle is 183, 120 degrees, right? Now, how to find coterminal angle? So you either add or subtract 360 degrees. Okay. So why that is the case? So let's start adding 360 degrees. So you start with 120 degree plus 360 degree. What do you have here? 480. So you might think that, okay, 480 degree, there is a choice here. But remember, you restrict yourself in between the interval between 0 and 30 and 360 degree. So 480 is not going to be the choice. You with me on that? Okay. So now let's do subtractions. 120 degree minus 360 degree. What do you get? Negative 240 degree. So it's between the interval of considerations. Now, in both counterclockwise and clockwise rotations. So if I cover the negative to 40 degree is in the interval of restriction. Okay, the negative is there to say that you go in the clockwise rotations. You with me on that? So therefore, the choice is D, negative 240. You understand my argument? You know why the choice is D and not A? Cool. All right. The next question is finding the coterminal angle of 500 degree. So 500 degree. If you add 360 is way off the chart, right? It's 9 between 0 and 360 anymore. Okay. So what you do is you do subtractions. 500 minus 360, what do you get? 140. Therefore, that is the answer. That is A. So let me write down a little bit details here. So 120 plus 360 give you 480 degree. Out of the restrictions. So that's not a choice. You also do 120 minus 360 degree equal to negative 240 degrees. So that is the answer. So for example 4, 500 degree minus 360 degree equal to 140 degree. And that is the answer. Now you have a radian measure of negative 2 pi over 7. You do subtraction in this case, then it becomes negative 16 pi over 7, which is more than negative 2 pi. So this is not going to be the answer. So what you do is you do negative 2 pi over 7 plus 2 pi. So what do you have here? 12 pi over 7. So you do negative 2 pi over 7 plus 2 pi, give you 12 pi over 7. What about number 6? Yes. A. Sorry. So you add with 360 degree and you should have 235 degree. Right, so for 3 pi over 4, there are two answers to the coterminal angles. So when you add 2 pi, be careful. So 3 pi over 4, you add 2 pi, and this gives you 11 pi over 4. Okay. And when you do subtractions, you have negative 5 pi over 4. So for these questions, I didn't apply any restrictions on the coterminal angle. This is a special case. Okay, so therefore the answer is C. So when doing this kind of problem, I will tell you exactly when to restrict the angle, when to